Hi everybody, I hope you have a good day. Today we are going to continue learning about scales, and we're going to focus mainly on changing scales. So what that means is you're given a model with a scale, and then you're asked to take that model and keep the actual dimensions, but change it to a new scale. Maybe you want a more detailed, maybe you want a bigger scale, maybe you want a smaller scale. It's just a matter of taking one scale, converting it to the actual measurements, and then taking the actual measurements and converting it into the new scale. So the first question, I've got two questions for you today. The first question is, you are planning a neighborhood. The rectangle shown is a scale drawing of the roof of a rectangular building. You used the scale 2 inches equals 75 feet. What would the dimensions of the roof be in your drawing if you used a scale of 1 inch equals 100 feet instead? So the first thing that we're going to do with changing scale is we are going to use our scale to convert it into actual measurement to new scale. So the first thing that we're going to do is we're going to take a look at our first scale. Our first scale is 2 inches equals 75 feet. So I'm just going to label that first, and then I'm going to label the second scale that we are given just as second, so that I know I'm going to first use the 2 inches equals 75 feet and then eventually use the 1 inch equals 100 feet. So what we're going to do is we're going to take a look at the length and the width. This is a little bit hard to read. This is 6 inches, and we're going to call that the width. And this is 8 inches, and we're going to call that the length. So I'm going to go over here and we're going to write length, width. Okay, just like before, we always use our scale. We take our scale, put it into a fraction form, drawing over actual. So I'm going to write a D over A. Our drawing over actual is our 2 inches over our actual 75 feet. And we're going to set up for our length, which is 8 inches. The 8 inches is the drawing. We're going to put that up top. Okay, and what is our jump from 2 inches to 8 inches? Well, we times by 4, so we're going to do the same thing on the bottom. So if I grab my calculator and, let's see, 75 times 4, I'm going to get 300 feet. So this is my actual length, 300 feet for the roof. I'm then going to move over to the width, do the same thing, set up that scale, 2 inches, 75 feet, and my drawing width is 6 inches. That's going to go on top. What's my jump? 2 inches to 6 inches times 3. Whatever we do to the top, we do to the bottom. So 75 times 3 is going to be 225 feet. And that is our actual dimension. So what I'm going to do, just so that we know what our dimensions are, I'm just going to write length equals 300 feet, width equals 225 feet. Okay, so now what I'm going to do, now that I have the actual measurements, I'm then going to take these measurements and convert them into our new scale. So even right below it, I'm going to take our second scale. So the red, that was the first thing we did. The second scale is going to be down here. Once again, drawing over actual, we're going to take that scale, 1 inch over 100 feet. Okay, and because we're taking what we actually know, this right here, this 300 for the length, that is the actual measurement. So that 300 is going to go in the denominator. And just like we did before, we looked at the jump. We're going to also look at the jump down here. 100 to 300. I'm going to times that by 3. What we do to the denominator, we're also going to do to the numerator. And 1 times 3 is 3 inches. So our new length for our second scale is 3 inches. I'm going to move on to our width, we're going to take that second scale again, 1 inch over 100 feet. And our width is 225. That is the actual length, so that's going to go in the denominator. Okay, and we've got to look at our jump. We're going to times by 2.25. So whatever we do to the denominator, we also do to the numerator. So we are going to get 2.25 inches. So now that we've gone from the first scale to the actual to the second scale, we now have our dimensions. So the new dimensions are going to be 3 inches by 2.25 inches. And this is going to be our new dimensions for our rectangular building. Okay, we're going to try a second problem. Okay, let's see if we can refocus that. So you're making a map of the United States. The map below uses a scale, 1 centimeter equals 100 miles. You want to use the scale 2 centimeters equals 125 miles. What will the dimensions of Kansas be on your map? Okay, so I see right off the bat, I see 2 different units. Okay, and I'm actually going to write this right here. Okay, so I have my first scale, and then I have a second scale. Okay, and just like I said before, we're going to go from the first scale to the actual to the second scale. Okay, and I'm actually going to I'm going to write the steps here. Okay, so the first thing we're going to do, use first scale, scale to find actual. And then you're going to use actual with the second scale. Okay. Oops. Writing on my table. That's okay. All right. So the first thing I'm going to do, we're talking about length and width. We're going to call the shorter side the width, the longer side the length, and that's just a matter of preference. I usually make the longer side the length. Okay, so we're going to do length and width. Okay, so once again, remember, we're going to do the drawing over the actual. Okay, our first scale that we're going to use is 1 centimeter equals 100 miles, or 1 cm over 100 miles. Okay, so for our length on our original drawing, we have 4 centimeters. 4 centimeters is the drawing. That number is going to go in the numerator. So we're going to put 4 centimeters. What's our jump from 1 to 4? Times 4. We're going to do the same thing on bottom. 100 times 4, 400 miles. Okay, so that's our actual. We're then going to shift over to the width. Same thing, guys. 1 centimeter over 100 miles equals, and this we have 2.1. What's our jump? Times 2.1. What's our jump? Times 2.1. We get 210 miles. Okay, so now we know that, I'm going to put this down here. So we have our length is 400 miles. Our width is 210 miles. And I'm going to use this in our new scale. Okay, it's going to be drawing over actual. I'm going to grab our second scale, which is 2 centimeters over 125 miles. And I'm going to set up our proportion. Okay, for the length, our length, our actual length is 400. So that actual 400, that's going to go in the denominator because drawing over actual. 400 miles. Okay, so now we're going to see our jump. I'll be honest with you, offhand, I don't know what that jump is. I don't know what I have to multiply 1.125 by to get 400. So the way that I'm going to figure that out is I'm going to go the opposite. And the opposite, I would usually multiply. The opposite of multiply is divide. So what I'm going to do is we're going to take 400 and we're going to divide by 125, and that is going to be our multiplier. That is what we're going to multiply by, and I can double check 125 times 3.2, and that's going to get us our 400. Okay, we're going to do the same thing to the top, times 3.2, and let's see, 2 times 3.2, just to be sure, 6.4 centimeters. Okay, and we're going to do the width, keep that new scale, and our actual width is 210 miles, so we're going to get that up here. Okay, guys, once again, I don't know what that is, so we're going to go backwards. We're going to do the opposite of multiply is divide. We're going to take 210 and divide it by 125. I'm going to get 1.68. So that's what I'm going to multiply both the bottom and the top by. All right, so I'm going to times that by 2, and I'm going to get 3.36 centimeters. Okay, and that's going to give us our new dimension. So at the end of the day, our new dimensions are going to be 6.4 centimeters by 3.36 centimeters. Okay. All right, ladies and gentlemen, I will have this copy as well as a blank copy of this on Schoology. You have one changing scale problem as a check-in. You're going to solve it on Kami, and I will see you guys tomorrow. Have a good one.